Hi, I'm Brian from Simply Brian Enterprises, and welcome to my channel. In today's video, we're going to be looking at the homework solution for TopTechBoy's Raspberry Pi Pico series, lesson number 13. In this lesson, we're going to be taking what we learned in the last lesson where we're sending values to the RGB LED, and instead of using just the single potentiometer that we used in lesson 11, we're going to have three potentiometers, red, green, and blue, to control all three color channels of the RGB LED. So let's take a quick look at the hardware. And first thing you'll notice is I had to reach back into my Sunfounder Raphael kit and pull out my three RGB potentiometers. I've got Paul in a red shirt, Paul in a green shirt, Paul in a blue shirt. They look a little worn. It's been a while since I pulled these out. But now I've got them properly identified as red, green, and blue. And I'm going to be using my other Pico for this one. This is just out of convenience because I wanted to have the potentiometers at the bottom of my breadboard. And also, it doesn't get a lot of love. I'm usually using the Pico Zero, so I thought, well, I'll just, or I should say the Pico W. Um, the, the standard Pico needs some love too, so I wired everything up to here. Same RGB LED, 220 ohm resistors, single cathode to ground. And I'm just going to install my diffuser here as I get ready to run my code. Let's see if the diffuser stays. It does, good. And I'm just going to go ahead and run this code. And we can see that we're outputting the value of the potentiometers. And I'm just going to start increasing, and we can see that the red is increasing. And we can also see that output value from 0 to 255. And I'm going to go green. We're going to go to, let's see if I can find that orange again. That orange was kind of nice. So I'm going to go all the way up on the red, and then green was about 64-ish. That's kind of a nice orange. Bring it up a little more, I can get more of that yellow color. We'll see, I don't know if the camera's going to pick it up or not. I've got my spotlight on it, but even so, it's not really showing up the way I'd like it to. And then we're going to go, let's just go all the way up and go to white. And there we are. So we have our different color mixes. Here I can take red out completely. Now I can bring in a more cyan looking color. And I can bring green out completely, bring us more to that magenta, the different colors that we made in our last video. Kind of fun that I can just color mix and make my own colors. I wish the camera picked them up better, but that's kind of neat. So let's take a look at the code, and what I want to show you here, if I can find the mouse, there it is. This code is essentially the same code as lesson 11. In fact, I'm not afraid to admit at all that I copied and pasted it from lesson 11 and basically just expanded it out 3 times. So instead of having a single potentiometer pin, I have 3. A single LED, I have 3. Setting up my PWMs, I have 3. Setting up my frequency and duty cycle on all 3 of them, and then I come down and I read not just one potentiometer, but 3 of them. And then I'm putting everything into basically just an R, G, or B value. And I'm coming down here again doing the slope intercept math that I talked about in lesson 11. Just doing it 3 times over, converting it from linear to exponential, taking out the corner case, and then writing it back to the LED again 3 times over. Now, where it gets a little more interesting is in this print statement. What I'm doing is I'm taking each of my colors, so I'm taking red, green, and blue, and I'm taking my percentage value because I know that's going to be between 0 and 100, and that percentage is the potentiometer input value, so that's always going to be linear from 500 to 63,000, converted to a percentage of 0 to 100. And then multiplying it by 2.55. So that way I'm getting a true representation. As I'm turning these potentiometers, I'm getting a true representation of 0 to 255 on a linear scale, and then the output to the LED is the exponential scale, but I'm not displaying that because that's not really part of the program in this case. Now, I had some fun with this, and since this is an extra credit assignment, I thought I'd have some fun. And I took a look at something that Keith had posted about a month ago, and I'll link to his video below, doing some string formatting when printing. And one of the things that he showed is using, being able to print a column width. So I wanted to actually here, let me go back to this. I'm going to show you what I'm doing, and you'll see. So I'm going to run this, and you notice when I turn the red that the green and the blue columns move around, and then if I move the green, the blue column moves around. So you can go when I go to a 3-digit value on red, a 3-digit value on green, you can see that the blue column moves over, and then as I turn it down and I go back to double and single columns in red and green, you can see that the columns shift around. And one of the ways we can stop that is by using column formatting. So I'm going to comment this out. And this print statement, the only difference between this print statement and the one above it is that the red is set to a width of 3. So you notice now that I'm changing the red, notice that the green column is not moving. It's just changing that number from a single digit to a 3-digit value, and the columns are all nicely lined up. Now, since I'm only doing the red column, it still has the same effect on the blue column when I turn the green, but this is just a good demonstration of how to do it on a single column, and you can see the benefit of that. And that's definitely something that I will be using in future videos, because that's really nice if I'm printing out, especially if you're printing out like the 16-bit value, 65,000, going out to 5 digits. It's really nice to format the column. But then we take it a step further. We not only format the red, green, and blue columns in 3, Keith showed us a trick where we can actually change the termination character of the string. Now, if you've done any programming in C or C++, you'll know that the way you print a string is you write out a character array, basically an empty array. You define the size of it, and then you send the data to the character array, and then you have to put a termination string. What do you do with it? Now in Python, we automatically terminate our string with what would be a \n, which is carriage return line feed. And what that means is, if you think of a typewriter, you're going to go, you get to the end, and then you go back to the beginning, and then you go down a line. That's carriage return, going back to the beginning, and then a line feed to bring it down one line. Well, what we're doing here is we're taking out the line feed. So we're just doing a carriage return. So I'm printing out this nicely formatted string, and then I'm saying carriage return, I'm going to go back to the beginning, but I'm not going to use a new line. And the beautiful thing about that is when I hit play here, notice that I only have one line. I'm not scrolling, and now as I turn this, it's going to update that line in place, and I don't get a screen full of output. I don't have a screen full of noise like I would if I was doing a carriage return line feed on every single print. And so that is a really neat feature that I guess I hadn't thought of before. So I wanted to say a big shout out to Keith. I'll link to his video below where he pointed this out. Really neat way of formatting the string to show the data better. So hope you enjoyed this lesson. Look forward to getting more done now that I'm back in the studio. If you like this video, be sure to hit like and subscribe below, and I'll see you next time. For Simply Brian Enterprises, this is Brian, and thank you for watching.